In Lesson 5, we're going to be solving problems by finding equivalent ratios. We're going to specifically look at two different types of ratio problems. We're going to be looking at total ratio problems and more ratio problems. And we'll see what those look like from the two examples. So example 1 says a county superintendent of highways is interested in the numbers of different types of vehicles that regularly travel within his county. In the month of August, a total of 192 registrations were purchased for passenger cars and pickup trucks at the local Department of Motor Vehicles, known as the DMV. The DMV reported that in the month of August, for every 5 passenger cars registered, there were 7 pickup trucks registered. So right there I'm seeing my ratio words. I can see it's a 5-to-7 ratio. I'm given that extra added information that there are a total of 192 registrations, and that's for both passenger cars and pickup trucks put together. Okay, so part A says using the information in the problem, write the ratio of cars to trucks. So if we have cars to trucks, I'm going to write it as a fraction today. The number of cars was 5. The number of trucks was 7. So it's a 5-to-7 ratio. Again, you can write it as the fraction, you can use a colon, you can use the word 2. Part B is asking us to make a tape diagram that represents the ratio. So I'm going to draw 5 boxes to represent the cars, and I'm going to line up 5 boxes directly underneath and then attach 2 more to make the 7 for the passenger trucks. Now here's where the added information kind of comes in. It first asks us how many equal size parts does the tape diagram have total? And here's that word that we're also seeing in the problem, total. So I'm going to count how many parts it has all together. So that means both cars and trucks put together. So we know we have 5 boxes for cars plus another 7 boxes for trucks. So all together there are 12 sections. You can count them, you can add them, however you want to do that total. So now part D says, since there were 192 total vehicles, how many of each type of vehicle were registered in the county in the month of August? So our extra information given to us on top of the original ratio is that there's a total of 192 registrations. Now the problems we've seen so far is where we're given how much is in one of the bars. But now, since we're given a total, we're given a number that represents both bars put together. So what we're going to do in this case is we're going to take the total given to us and we're going to divide it by the total number of sections. Okay, so we're taking the total given to us, or 192, and we're splitting it up over the 12 sections. Okay, so the total represents both bars all put together, and we're splitting that total up over each of the sections. So we have to do 192 divided by 12, which gives us 16. What this means is the 16 is the number in each section. Okay, so we took the 192 total, we split it up over the total number of sections, and we got 16, which is the number that will go in each section. I'm just going to work off of this because it's already drawn up here. I'm showing my 16 goes in each section. Now to figure out how many of each vehicle were registered, I'm going to take the number inside each section and multiply it by the number of sections. So for cars, I'd be multiplying by 5, and for trucks, I'd be multiplying by 7. So there would be 80 cars and 112 trucks. Now, there's a way you can check yourself with this problem. Remember, they told us we should be having 192 total vehicles. So, both of these should add up to make a total of 192, which they do. So there would be 80 cars and 112 trucks. So in a ratio problem where you're given a total number of the two bars, you take that total, you divide it by the total number of sections, and that gives you the number that goes in each section. The next type of problem we're going to look at is a more problem. So this example says the superintendent of highways is further interested in the number of commercial vehicles that frequently use the county's highways. He obtains information from the Department of Motor Vehicles for the month of September and finds that for every, here's our ratio words, two non-commercial vehicles, there were 5 commercial vehicles. So now we're looking at non-commercial, like mom and dad's car, versus commercial vehicles, like those big Target trucks that you see driving down the highway. So using the information in the problem, write the ratio of non-commercial vehicles to commercial vehicles. So I'm going to use NC for non-commercial and C for commercial. So it's telling us there's 2 non-commercials for every 5 commercial vehicles. So that's a 2-to-5 ratio. It wants us to now make a tape diagram that represents the ratio. So 2 boxes for non-commercial and 5 boxes, notice I'm lining up my first 2, for commercial. Now, in this problem it's asking us for the next piece, how many more equal size parts does commercial vehicles have? So it's basically asking how much larger is this number in the ratio than this number. So I can look at it as how many extra pieces there are hanging off the end here, and this is why it's going to be very important to line those ones that match up, lining them up. So if you look, you can see there's 3 extra parts here. So to figure that out without the tape diagram, I'm taking the number in the commercial vehicles and subtracting out the non-commercial vehicles. How many more? Tells us we're subtracting to get the 3 that way. Now there is another piece to this problem that wasn't added in the original, and it says if there were 108 more commercial vehicles than non-commercial vehicles, how many of each type of vehicle frequently use the county's highways during the month of September? So in this case, I'm given a number more. That number more represents the number of sections more. So this is 108. So when you have a problem where you're given a number more, you're going to take the number more given, or the 108 in this case, and you're going to split it up over the number of sections it represents. So 108 represents these 3 sections. So that 108 is being split up equally over those 3 sections. So we're taking the number more, dividing it by the number of sections more, and that's going to give us the number in each section. Okay, so I'm going to do my 108 divided by 3, and I am going to get 36. Okay, so that means 36 would go in each section. Okay, so to figure out, and I'm just going to rewrite over here because I made kind of a mess there. For my non-commercial, I'm going to take the number in each section, multiply it by the number of sections, which is 2. And for commercial, I'm going to take the 36 in each section and multiply it by the 5 sections. Okay, so now based on the problem, we can check our work. It's telling us that there are 108 more commercial vehicles. So to figure out if this is accurate, I can take the commercial and subtract the non-commercial from it. and see if I get that 108, which I do. Okay, so in this type of problem, if you're given a number more, you divide it by the number of sections more, and that will tell you which number goes into each section.